Hi everyone. Today we're going to introduce a third method that we could use to solve a system of equations. So you might recall that the first method we used was by graphing the two equations, right, and finding where those two graphs intersect on the plane. We then went on to do the substitution method, right, by solving one equation in terms of x or in terms of y, and then subbing that into another equation and simplifying. This third method that I'm going to introduce is called the elimination method. And I think, quite honestly, the elimination method is usually our most favorite method, I believe. Right? So what I'm going to do is I'm just going to start by doing an example, because I think that might be the easiest way to show what I'm doing. So I'm actually going to keep these lined up. So here's my game plan. I see that both equations have a 10x, or sorry, both of the equations have an x and a y term. And so what I'm going to try to do is, by lining up both of my equations, I'm going to actually try to eliminate one of my variables, right, by adding or subtracting. So let's see here. On the top equation, I have 10x plus 6y equals negative 38. And on the bottom equation, I have 8x plus 3y equals negative 25. Before I even get started, I'm going to go ahead and let's label each one of the equations just so I could refer back to it if I needed to. Let's go ahead and label this top one. Let's label this one equation 1. And let's label the bottom one equation 2. So what I want to do is, I see that I have x terms in both of them and I have y terms, and I want to eliminate one of my variables. So what I need to happen is I need to have the same number of x's in each of the equations, or I need the same number of y's in each equation. Right? So I have a 10x in the top and an 8x in the bottom, and I have a 6y in the top and a 3y in the bottom. So I'm trying to think, which one would be easier, which variable would be easier for both of the equations to have the same number of that variable, right? And so I see I have a 6y and a 3y. I think I could turn this 3y into a 6y, and that's exactly what I'm going to do. I am going to go ahead and multiply the bottom equation by 2. And the reason I'm going to multiply it by 2 is because I want to turn this 3y into a 6y, right? Because I want the same number of y's in both equations. So when I do that, first let me just rewrite my equation number 1 here. 10x plus 6y equals negative 38. 10x plus 6y equals negative 38. And then I see I have this 2 up front in my second equation, so let's go ahead and distribute that through. So 2 to the 8x gets me 16x, and then 2 to the 3y gets me plus 6y. And then on the right side, negative 25 times 2 gets me negative 50. So now I have the same number of y's in my top equation and my bottom equation. So what I'm going to do is I want to eliminate my y's. So I have a positive 6y here and a positive 6y here. So I believe that I need to subtract my entire bottom equation in order to eliminate my y's. Right? And so when I subtract the bottom equation from the top equation, 10x minus 16x gets me a negative 6x. And a 6y minus 6y gets me 0y, right? So I don't even need to write that, really. But then I have negative 38 minus negative 50. And if you used a calculator on this, that would be a positive 12. Okay. And so now I have negative 6x equals 12, and I think we could solve from here. Let's go ahead and divide both sides by negative 6. So I get x equals negative 2. So now I have x equals negative 2, and I think that was much faster than it would have been with the substitution method, right? That's why the elimination method is probably most people's favorite. Really, the hardest part about it is figuring out what equation, first of all, what variable do you want to eliminate? And secondly, what, if any, number do you need to multiply to one or both of the equations? So now that I have x equals negative 2, let's go ahead and find the value of y. And so to do that, I could really take either equation 1 or equation 2, it does not matter, and solve for y. So let's go ahead and take, for no particular reason, let's go ahead and take, how about equation 2? So from equation 2, we know that x equals negative 2, and our equation is 8x plus 3y equals negative 25. So I'm going to go ahead and sub in this x equals negative 2 in for my x over here and solve for y. So when I do that, I get 8 times negative 2 plus 3y equals negative 25. This is just simplifying. So 8 times negative 2 is negative 16 plus 3y equals negative 25. And then we'll go ahead and add 16 to both sides. So then I get a 3y equals negative 25 plus 16 is negative 9. Let's divide both sides by 3. So I get y equals negative 3. Y equals negative 3. So now I have x equals negative 2 and y equals negative 3. So my final answer in terms of a point would be negative 2, comma, negative 3 in parentheses. And again, because our answer is an actual point, that means I know that this system is consistent and independent. Consistent and independent. Okay. Again, I know we have not done any of these via substitution or elimination where we get a consistent and dependent or an inconsistent, but we will get to that eventually. Okay, let's try one more using the elimination method. Here I have 4a plus 10b equals negative 46, and a 9a plus 15b equals negative 81. So no different, even though now we're using a's and b's instead of x's and y's, no different. I still just want to find out whatever a equals and whatever b equals. So here I need to figure out what do I want to eliminate. I can either eliminate my a's or I can eliminate my b's. This one is a little bit different because on the previous equation, and go back to that for a second, on the previous equation, all we had to do was multiply the bottom equation by 2 in order for our y's to match up. Unfortunately, I don't think that there's a nice integer that I can multiply only the top by or only the bottom by so that our a's or our b's would match up, right? 4 does not go into 9 and 10 does not go into 15. So on this one, what I'm going to have to do is I'm going to have to multiply the top and bottom, each of them by a number. And let me go ahead and write this in a little more pleasing way. Let's multiply this side and then this side. So the question becomes, what number do I need to multiply the top by, and what number do I need to multiply the bottom by? Right? So really, I'm thinking the 4 and the 9, I could eliminate my a's, but I'm liking the 10 and 15. For some reason, I just think it'd be easier to eliminate the b's here. So what number do both 10 and 15 go into? Right, well, I think 10 and 15 both go into 30. So what I'm going to do is I need to multiply the top equation by a number so that I get 30b. Right? So what number times 10 gets me 30? Well, that's going to be 3. 3. Let's multiply the top equation by 3. And then on the bottom equation, I have that 15b, and again, I'm trying to think 15 times what number is going to get me 30, and that's going to be 2, because 15 times 2 is going to get me 30. So now let's go ahead and distribute both of these numbers through our equations. So on the top one, I'm going to distribute that 3 through to everything. Right? So on the top one, I get 3 times 4a gets me 12a, and 3 times 10b gets me 30b. And that's going to equal negative 46 times 3 is going to get me negative 138. On the bottom equation, I'm going to multiply everything by 2. And so, let's see, when I distribute that 2 through, the 2 times 9a is going to give me 18a, and the 2 times the 15 is going to get me a plus 30b, and that's going to equal negative 81 times 2. Negative 81 times 2 is going to be negative 162. So now my b's are lined up, so I just need to reduce out my b's, cancel my b's. So I'm going to go ahead and subtract the entire bottom equation. When I do that, 12a minus 18a is going to get me negative 6a. 30b minus 30b gets me 0. That reduces out. And then negative 138 minus 162, if you used a calculator, would be a 24. 24. So now from here, negative 6a equals 24. Let's go ahead and divide both sides. Negative 6. And so I'm going to get a equals negative 4. We have now done one half of our problem. Now I just need to find the value of b here. So I can take either one of these equations from the beginning and substitute in my a value to find my b value. Okay. So let's call this top one, let's call this equation 1, we'll call this equation 2. I'm going to go ahead and substitute my a into one of my equations. It truly does not matter which one. I'm going to do from equation 1 for no particular reason. So from equation 1, we know that a equals negative 4, and my equation is 4a plus 10b equals negative 46. So let's go ahead and sub in a equals negative 4 into this a. When I do that, I get 4 times negative 4 plus 10b equals negative 46. 4 times negative 4 plus 10b equals negative 46. Simplifying here, negative 16 plus 10b equals negative 46. Let's go ahead and add 16 to both sides. Get rid of that. Whoops. Okay. When I simplify this, I get 10b equals negative 46 plus 16 is a negative 30. And then we'll go ahead and divide both sides by 10. So I see that b is going to equal a negative 3. b equals negative 3. So now my final answer in terms of a comma b, in terms of a comma b is going to be negative 4 comma negative 3. And again, this is consistent and independent. consistent and independent. Wonderful. I do have one more thing I wanted to point out with a new system here. I'm not going to actually solve this one. I'm just going to talk about it for a minute. So if I had 3x plus y equals 4 and 4x minus y equals 10, I see that I have 1y here, and this is actually a negative 1y in the bottom equation. So it looks very tempting, like I could go ahead and subtract the bottom equation. However, when I did that, if I did that, I would get 3x minus 4x gets me negative x, and that's fine. But the problem is I have this positive y minus a negative y. And so what happens when we have minus a negative? Well, that turns into addition, right? So this is actually y plus y, which would get me a 2y, right? And so that actually doesn't really help me. So what I need to do is be very careful, and I could either do one of two things. Either A, instead of subtracting the bottom equation, I could add the bottom equation, right? And when I added the bottom equation, I would get a 3x plus a 4x is a 7x, and then y plus negative y, that would reduce out to 0, right? So that would work out nicely. And then I could continue solving the equation like this. Or if I wanted to do something different, I could, let me just rewrite this here. If I had a 4x minus y equals 10, if I wanted to make this y and this y have the same term, what I could do is multiply the bottom equation by negative 1. And so then, let me rewrite the top equation. 3x plus y equals 4. And then when I multiply the bottom equation by negative 1, I have a negative 4x plus y equals negative 10. And then I could go through and now subtract the bottom equation off. And that would work out just fine, right? 3x minus negative 4x, 7x, and y minus y is 0 again, so that reduces. And then 4 minus negative 10 is a 14, right? And so these two, you can see that these two are both the same. 7x equals 14. Okay, just be careful on if, one of the equations is a plus, is a positive, and the other one is a minus, a negative, right? Make sure that that is the same sign if you are to subtract them.